Okay, now we are doing question 4, which is momentum. Also November 2022. So let us read. The statement says you have trolley X of mass 1.2 kg traveling at 8 meters per second east and collides with trolley Y of mass 0.5 kg, which was initially at rest. Ignore if frictional effects, and then the velocity time graph below shows the velocity of trolley X before and during after the collision with trolley Y. So let me give you a picture of what is going on here. Imagine like you have trolley X. Let's say this is trolley X. This is trolley X, which is 1.2 kg. And this side is going to the east. And the velocity is 8 meters per second. And then there is another trolley, which is trolley Y. This is trolley Y, which is 0.5 kg. And they said now this one is stationary, which means the velocity is 0. Now this is happening before, and then there will be a collision there, and then this is trolley X after collision, this is trolley Y after collision. So this is after collision. So we don't know the velocity after. We don't know the velocity after. So in fact we can know for trolley X because this is the time graph for trolley X. So this one was before. So this was the velocity of trolley X before. At this point something happens to trolley X. We know here there is a collision, and then this is the velocity of trolley X after collision. So we know the velocity of trolley X after collision became 4 meters per second. So the time here from 20,1 to 20,3, this is the time of the impact, which is 0,1. 20,2 minus 20,1 is 0,1. That is a time during the collision, the time of contact during the collision. So let us look at the questions. State the principle of conservation of linear momentum. State the principle of conservation of linear momentum. Now the principle says 4.1. Let's use another color. It says okay, what's wrong with my black now? Black color is not working. Okay, yeah, it says in an isolated system, the total linear momentum of an object is conserved. So there are few words here that are very important. The first one is in an isolated system, the total linear momentum is conserved. So they will give you 2 marks for mentioning these words. Now calculate the magnitude of the velocity of trolley Y immediately after collision. So we want now the velocity of trolley Y. We want this one, the velocity of trolley Y after collision. Remember, the velocity before was 0. Now we want the velocity after collision. So this one is 4 max, that's 4.2.1. So 4.2.1. So we have the sum of the momentum before is equals to the sum of the momentum after. So then we have m1 v1 plus m2 v2 is equals to m1 v1 plus m2 v2. So this is before, this is after. So this is trolley X, which is 0.5. The initial, remember I forgot to write the direction here. Right is positive. This is the direction, right is positive, and the velocity of, oh sorry, trolley X is 1,2 and the speed is 8. Okay, I think we made a mistake here. The trolley X, the mass of trolley X is 1.2. The mass is 1.2 and the velocity is 8. Because of it's going to the right, we took right as positive, so the 8 is positive. Plus this one, trolley Y is 0.5 and the initial velocity is 0. And then after collision, trolley X is 4 meters per second to the right and the mass is still the same. So it's still 1.2, then it's 4 meters per second. Now we want now the velocity for trolley Y. We want the velocity for trolley Y. So you take a calculator and then you set 1.2 times 8. 1.2 times 8, and then the answer is 9.6 here. Plus this one is 0. 1.2 times 4. 1.2 times 4. That is 4.80. Plus that one is 0.5. So we want the V final square for trolley Y. So we'll take this one. Okay, V final for trolley Y is 0.5. So we take this one to the other side. So we have 9.6 minus 4.8. 9.6 minus 4.8. 9.6 minus 4.8. So we have 4.8. So this side is still 0.5 V final Y. So let's divide by 0.5 on the left, divide 0.5 on the right. So V final Y is equals to, so divide that by 0.5, which is 9.6. So the answer here is 9.6 meters per second is going to the right. So that is 4.2.1. That is the velocity of trolley Y. Let's write it here. The velocity of trolley Y is 9.6. It's 9.6 meters per second. So the following question says, now calculate the average net force that trolley X exerts on trolley Y during the collision. The net force that trolley X exerts on trolley Y. So the formula, it says F net times change in time is equals to change in momentum. So this is the same as m v final minus v initial. So we're going to divide by time. So this is the same formula. So we're looking at trolley X, the mass is 1.2. The final velocity for trolley X is 4. The initial velocity for trolley X is 8. So we have 4 minus 8. Final is 4, initial is 8. And the time during the collision is 20,2 minus 20,1, which is 0,1. So that is the change in time, 0,1. Then take the calculator, then we said 1.2 multiplied by 4 minus 8. The answer is that you divide that by 0,1. So the answer is negative 48 newtons. But you must not leave your answer as a negative. So you must just say it's 48 newtons to the left. 48 newtons to the left. So that was 4.2.2. And the last one is the collision elastic or inelastic? Explain the answer by means of suitable calculations. Is the collision elastic or inelastic? So that was 4.3. So this one you can do it like by looking at the sum of the kinetic energy initial is equal to the sum of the kinetic energy final. So the kinetic energy of trolley A or trolley X, m1 v1 square, plus the kinetic energy of trolley 2 initial, the trolley 1 final, plus the kinetic energy of trolley 2 or trolley Y final. So you have 1, the mass is 1.2, the velocity initial is 8 square, this one is 0,5, the velocity is 0 square, this one is still 1.2, the velocity final is 4 square, plus this one, the mass is 0,5, the final velocity is that 9.6 square. Then take a calculator, then we said half multiplied by 1.2 multiplied by 8 squared, then we have 38.4. Let's look at this one, is 0. Let's look at that one. So we have half times 1.2 times 4 squared, which is 9.6, plus the last one, we have half times 0.5 times 9.6, 9.6 squared, then the answer is 23,04. Then on the left we have 38,4, and then on the right we have plus 9.6. So on the right we have 32,64. So you can see that this and that is not equal. The sum of the kinetic energy before was bigger than the sum of the kinetic energy after. So this means that the collision is inelastic. Is inelastic collision because the initial kinetic energy, or the sum of the initial kinetic energy is not equal to the sum of the kinetic energy final. So that's how you do this one. So I think that was the last answer. Yeah, that was the last answer. Yeah, 4.3. Okay, yeah, that was the momentum that was done last year, 2022 November. Okay, the next video will be on your inorganic molecules, or your organic molecules in paper 2, question 1, 2 and 3. I'll see you in the next video.